Okay, here we have a question about magnets. Not very often that we get one in IB about magnetic fields, so it's nice to see. As ever, please have a go over the question, and then when you're ready to see an explanation of the answer, hit play. Okay, so like I say, I've not seen many questions like this, and I would be honest with you, I'd be delighted to get this one. Okay, we want to know the correct magnetic field lines. Okay, we have two magnets, and then we've got north, 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 always facing each other here. Okay, so we need to remind ourselves, how do we know the direction of a magnetic field line? Well, the answer here is CY. Magnetic fields show the direction of force on a north pole if placed at that point in the field. And this is the tricky bit of the question. We ask the question, what would happen if we put a north pole at that position in the field? Much like we talk for electric fields, we say, what would happen if we put a positive point charge there? In magnetic fields, it's all about what would happen if we put a north pole. Now, why is the answer C? Let's go through the other answers and explain why they're wrong. We take the example of this one here. Okay, if I were to put a north pole at the top location here, for example, it would be repelled by both of the fields. So the left hand, by both of the poles. The left-hand pole would push it right, the right-hand pole would push it left, so we would have no arrow to the right or to the left. Okay, now notice these two drawings here, they show arrows in opposite directions. That also doesn't make sense, okay, because we would expect this thing to be symmetrical. D seems sort of like it could make sense. However, remember, our north pole would be pushed away from the pole, which is why C is correct. You can see here that if I were to place a pole here, then we'd have those horizontal components cancelling and simply a force pushing out. Similar on the bottom, and that's why the answer here is C. Now, interesting to note, there are no field lines in this location. What does that mean? It means that the field would be zero. So if I were to place my north pole at the point right in the middle here, there would be no net field. In other words, our compass would just simply start spinning because it wouldn't have a net. It would have zero force, zero field acting on it.